Making a TikTok.
Oh, you should be going.
Oh, it is going. Okay.
I think.
All right, here we go. Welcome to the March meeting of the Baton Rouge Astronomical Society. Thank you, everybody, for coming out. This is we're continuing with this large participation at the meeting, so that's great. Thank you, everybody. As we do, we're going to start with our little presentation, and have a short little coffee break, and then we'll do some of the short club business, and we'll see what the sky is like outside, whether or not we'll be able to do any kind of observing activities. Scott, would you like to take over, or do you want me to do the introduction? Scott can take over. It's his job.
So the beautiful thing was, after sitting around and I've been talking with a bunch of people, and you hear about this radio podcast, that everybody was starting to say, well, you know, we're sending people back to the moon any minute now, and there doesn't seem to be a full bunch of enthusiasm for the fact that we are putting people on the moon for the first time since the first part of the 1970s. Well, since 72, 17 the last one. That's.
But we're talking landmark at the start of the minute.
Yeah, no, but in terms of the landmarks of stardom, we left the moon in 72.
Yes.
And we haven't been back since. But we're going back. We're going back soon. But there seems to be a lackluster of real enthusiasm. The first mission was supposed to launch sometime in the middle of February, and there were a whole lot of launch parties. There were a whole bunch of people doing newscasts and things like that. This is not in the main stream of the, not on the local channel. Okay. So I thought, well, let us grab our local solar system ambassador, who is Amy Northrop, who has been with us for years and is always willing to come and speak to us about what's going on with the NASA mission, and have her come talk about quite possibly the largest space program of our generation, which will be us going back to the moon. And originally, I had hoped to get her here for an actual loop around the moon, which is this Artemis 2 thing scheduled. That was also rescheduled to later this week, and is now further rescheduled to April. But I'm sure she'll
Yeah,
so, but in the process, she's gone a little bit further, and she's agreed to part of the Artemis mission and where they're going, especially after they have just done a massive release of targets, which she has graciously had the time to fill out and understand. So without further ado, I'm going to hand this over to Ms. Northrop and allow her to present.
You got me so excited. I just wanted to dive in. So first disclaimer, I am a volunteer with NASA. My opinions don't reflect any regarding NASA or JPL or the observer. So legalese out of the way, let's get started with the fun stuff. Going back to the moon. So Artemis 2. Its wet dress rehearsal revealed this is actually a helium leak. They just revealed that recently. The helium was not a hydrogen leak and the launch has been delayed. So when can it launch now? These are the remaining launch windows that have been announced. The next one being April 1st. Yeah. I saw that and I'm like, oh no.
Yeah.
Oh no. So these are actually slides I got from my training in January when they were bringing us up to speed on the impending launch. So some of it's a little dated, but don't worry, I can cover updates at the end of the stuff. But if you see this in the corner, it's an access slide that NASA will graciously allow all of their ambassadors to use. So Artemis is taking us back to the moon for the first time since the Apollo program. It's going to be the first time we have people on the ground, and hopefully we're going back to stay, just as the Apollo program originally intended before the budget. And here you can see the Orion capsule tucked safely in its bearing the top of the Space Launch System. So the reasons why we're going, scientific discovery. You can only learn so much about the moon by just crashing spacecraft into it or landing. Yes, we actually did that more than a few times. Just crash it and see what gets picked up. Because science. Inspiring new people. Most people haven't had or experienced a mission. I haven't seen anyone land on the surface of another astronomical planet, and I'm grateful too, because space, science.
It was.
Yeah.
See, even more reason. There. I'm jealous. And also economic benefits. There's a lot of resources in space. I don't know if it can be learned in space. A lot of technologies that we use every day were developed by NASA. But NASA doesn't maintain, they have the patents, but they can't profit off of anything that they design for space. Polarized sunglasses, based on buys the Apollo. Yes, because who wants to have a ported drill connected to your lamp? Yeah, that would have been fun trying to drag that thing in the rover. So, Artemis won the first mission, which flew around the moon in a very complicated orbit. It was called a retrograde orbit, and it basically did this little spiralish design around the moon to keep the spacecraft in space for 30 days, with the intent of putting as much stress on the capsule as possible. This is the first crewed mission, and we'll meet these lovely four folks in just a second. Artemis 3 was planned to be the first surface landing. This is no longer the case. And these have also changed. I will cover those updates after we get to the next slides. These slides were given to me in late January. And a lot has changed with Artemis. So the crew. These two are the mission specialists, Jeremy Hansen and Christina Koch. This is pilot Victor Glover, and this is Commander Reed White. And they will be orbiting the moon, which here is the flight path. Launching from Kennedy, and they're going to get up into orbit. Yes, this is their raise for translunar injection because of the orbit taken. And during this point here, they're using something called the interim cryopropulsion stage, which basically serves as a little booster rocket, and then they will kick it loose and speed one. And then they will just fly the rest of the way with the tab module, which is basically the service module that's provided by the sun. This is what's called a free return trajectory, and it has been used since the days of Apollo. And unlike the Apollo program, these capsules would be picked up by an amphibious vehicle from the U.S. Navy. They have a little wet bay for like watercraft to go out, and they will go out with a speedboat, take the capsule, bring it in, close it, drain the bay, and then the astronauts can get out. There's no need for the astronauts to get out of the capsule until it's safely into the cover. So Artemis 2 is going to be amazing because there's so much science involved. It's going to be our first chance to do civil lunar science with people. And this is the first time since 72 we will be close to the moon. Does anyone know who the astronaut who was, or human, who was flown the furthest from the Earth? Okay, besides you, since you seem to know who it is.
Does anybody other than the person who knows who it is know who it is? Yeah. Okay.
It was Jim Lovell. The others were hugging the moon, taking photos while he was doing math calculations for their own. And he jokingly told them that if they didn't get back to Earth, they wouldn't be able to develop the film. That they needed to focus on the task and quit being lunar tourists. But he had already gone around with it. The orbit is not fixed, and we will change it as necessary for mission parameters. But we've used the Lunar Reconnaissance Orbiter and other satellites to help refine the orbit and find stuff. So, and this is also what they're using to determine data for future missions as well. So these are going to be the scientists. So here they'll be doing Earth imaging. Oh, what's going on? And here they're going to get up into this position, and then they're going to start the path. Here they will check all of the data, and this is where they will finalize what science they're going to do on the closest approach. And this is their real flyby where they'll use most of their science. Here they'll relay the data, and then they will come back home. This will take roughly 10 days. Yes, one of the orbit moving notes. That is not in this mission plan side.
Well, that would require an electro burn at the other end, you put your turn on.
Yes. And
And
basically the way this orbit is set up, the moon will fling them back to the Earth. They won't have to expend any fuel until they're slowing down to actually come back home, like into Earth atmosphere. Yes.
So you said the mission will take like 10 days. Do you know how long from the, like, the lunar file review to the post lunar flyby?
They have not given specific breakdowns on it. They have just said the entire mission will take 10 days. I am assuming here it will be standard 4 days to the moon and 4 days back, like it was with the Apollo program.
Yeah.
what's this?
Well, Apollo 8 actually orbited. It
Yeah,
actually stopped and orbited. Yeah. So they have 10 science objectives. They are want to check color provinces and albedo, which is how bright an object is. Objects that appear brighter are said to have a high albedo or reflectivity of. They want to see if they can see any impact flashes on the moon. They also want to see if there's any photometric changes, like changes in the lights and flash observations. They want to check landing sites primarily at the lunar poles because those are great scientific interests. Impact history, depth and exosphere, and they also want to see if the moon has tectonics. We actually don't know much about the interior of the moon, even though we've sent people there before. Only 12 people have gone there before that, not much to do science. On 12, it was a seismometer, and the S4B of Apollo 13 actually crashed into the moon and rang the moon like a bell, which is part of what kicked off the theories that, oh, the moon is hollow. No, the moon isn't hollow, it's just weird and we need to learn more. We also want to see about volcanic history and also the Earth from space, because who doesn't want to see the full sphere of your home? And these are the different capacities we have, which captured by Apollo 8. They saw it on their first orbit and they captured it on their second. And here are the different ways in which they will achieve these objectives, different data capture, flight news report. They're also going to look at archival data and compare it to modern. And also, as always, we're sending cameras to the moon because science and it works. So this is called an organ ship. So it's called Avatar. It stands for a virtual astronaut tissue analog response. There are 4 of these chips flying, each grown from tissue donated by the astronaut. And basically, they are in a little special storage box to keep these tissues alive. And they act like in miniature to study different parts of the astronaut's anatomy and judge their vulnerability. In this case, bone for this group, but they have these much bigger chips where you can grow tissue from lungs, all kinds of stuff, and see how people respond to them. But they're just doing a this size chip, which is about the size of a USB stick. And it's baby miniatures of the astronauts to study how their bone marrow responds. And actually, the logic is that since humans have multiple layers and are better insulated because we're a very complex organism, having just the tissue from set areas being more vulnerable can catch issues early. Say one tissue develops an anomaly, they can watch that astronaut more closely on future missions because it doesn't have the same added protection of being in a complex human body with fully functional immune system. Yeah, I learned about these and I'm like, oh, this is amazing. No one's gonna believe this. Bone marrow. But bone marrow issues are some of the most difficult to treat, and if you can catch them early,
A lot of radiation.
yes. So they're the size of a USB chip. They contain living cells connected via blood donation. Though the actual presentation said bone marrow. And it mimics how organs function. They breathe like a lung, they can beat like a heart, or they can process like a liver. They're basically a little miniature copy of that astronaut. And they're known as tissue chips and microphysiological systems. So basically they have a little mini them or a mini part of them on a ship that's going to go up in space with them. So the experiment. Yes, I was correct. Bone marrow. It studies the individualized effects of deep space radiation on individual actions, along with microgravity. And it used bone marrow cells developed from their blood samples. So it's bone marrow, but it was developed from their blood, which makes this a whole new level. And it's going to be good for diagnosing diseases, engaging their immune system response, and moving forward. The cells are inserted into organ chips and secured in custom hardware, which they fly inside this box, which maintains the environmental control and provides them with the nutrients and growth needed for this organ chips to remain healthy. And they will use single cell RNA sequencing to check them, and they're going to compare these to what the astronaut exhibited before the flight and what the astronaut exhibited after the flight. With the pre-mission one being the control space. And if you want to learn more, you're welcome to scan the QR codes. I knew at least one person would. You need to open up the second one? Yeah. Let me know if you need, anyone else needs a moment to scan the QR codes. Okay. I knew this would be a hazard, but I'm sorry the organ chip's too cool not to include.
We could put it back up there.
That's cool.
I mean, theoretically, people could just take a picture with their camera instead of scanning it.
So, human health science on Artemis. There are several hazards, which they use the acronym BRIDGE. First, space radiation. Humans evolved on a nice planet with an ozone layer and a magnetic field. We don't see radiation. It is not good for us. We do not like it. It can cause hazards with our DNA, our cells, and other ways, which is part of what the organ chips are studying. Also, isolation and confinement. As all of us experienced 5 years ago, and anytime there we experience a snowstorm, we go a little stir crazy. We want to get out and walk around the block. You can't do that in space. Because you have to suit up, depressurize, and then you can go back outside. Inflated full atmosphere. So you actually have to decompress. You have to go through a decompression and then a recompression. Which is why everyone's like, well, why does it take so long for them to do a spacewalk on ISS? A spacewalk is the longest part. It's getting them adapted to the spacesuit and then back to the capsule on ISS, which is Earth standard in case they have to do an emergency back to Earth surface. Distance from Earth. It's one thing to travel to another country, but leaving your planet is something not everyone might have the mental enthusiasm. I would too if someone's paying for it. I'm not paying for it. And gravity. We designed for 1G, that is what we evolved for, what we live in, and we need it to maintain health. They've shown that the bones degrade even with exercise on ISS astronauts. So this is something that we have to overcome for long-term habitation in space. And there's also the fact that you're in an enclosed environment and outside the field. So that is a psychological threat as well as an actual physical health aspect. Sun, we love it until we don't.
Can't predict it either.
Mm-mm. Yeah, everyone keeps telling me, oh, you're gonna see some nice northern lights on your trip, and it's like, maybe. And part of the problem with confinement is there's no real privacy in the Orion capsule. So think about that. You're in an area, granted it's bigger than the Apollo capsule, but there's an extra person in there. So you have to deal with the fact you can't get away from someone, from your crewmate if they get on your nerves. Distance from Earth. There's ISS, which if there's a threat, you can get back immediately. The moon, help is 4 days away. Mars, 6 to 18 months. My favorite water bubble experiment was when they actually put food coloring and then stuck an alpha cell tablet in there. You could just watch the little bubble boil from the alpha cell. And you have to wonder how long did they have to wait or try to get the bubble ideally positioned for the shot. So lack of gravity. They're going to be without gravity 10 days on Apollo, or Artemis 2. But the period of decrease and microgravity will increase with future missions because we're hoping to build permanent habitation on the moon. Hoping. So you also have to deal with an additional gravity type here. You have to deal with microgravity, both on the trip there and on the gateway, which I will discuss in a little bit, and 1/6 gravity on the moon. And then after that, you have to come back home and experience a normal gravity, or what we human physiology considers a normal gravity. As I said, no one likes to snap the conditions outside, especially when you don't have the option to go anywhere. So, cool, more space science. We already talked about Avatar. So, Archer. Artemis 2 crew members are going to wear a wristband that is going to track their movement and sleep, to monitor how their behavior and sleep is changing in microgravity, and also to see how they handle stress and cognition. And it also includes their pre-flight and post-flight tests for motor control. And the data will help with health monitoring and mission planning. I didn't realize that you had to go into NASA to have one of those. Wonder how much NASA paid for that, because mine, one. So, who here has ever seen the pool test strips? Like, the pool test strips that they use to test chlorine and pool.
Oh, yeah.
They have them for their saliva, not pH, but they basically, they can, it says immune biomarkers, but it can actually be used to shed on a lot more than just the immune biomarkers. They basically are collected in these little booklets, which you can see this on, and they're stored dry, no refrigeration necessary. And they can later be tested to see how their body responded to stress hormone, viruses, and even cell changes. And it'll help give us insight for crew health on long duration missions. But the little colors on the cover reminded me of one of those little test strip bombs. Yes.
Have they done any of this on the ISS already?
It seems to be in some stages of implementation that they haven't published any data set. It was finished in 2000, November 2000.
Things happening, so what does this add in data exposure compared to somebody?
Well, there's two sides to that. One, ISS is largely protected by Earth's magnetic field.
Yeah.
Whereas on the way to the moon, you actually have to pass through the Van Allen radiation belts, which Apollo and subsequent tests have proved the threat to of the Van Allen belt is minimal because of how spacecraft are designed. Really no threat. Unless you want to park your spacecraft here just for laughs, which I don't imagine anyone's saying doing. But once you get past the Van Allen belt, your out paths are protected bubble. And the moon has no protected bubble. So you're relying purely on your spacecraft rather than Earth's natural defenses. So Artemis Standard Measure, this will be the first deep space crew to join this study. All astronauts and guinea pigs. So they're going to provide a wide variety of tissue samples to help scientists understand what's going on to their changes. The most famous study with astronauts was the twin study that happened with the Kelly brothers. One of them, both astronauts, and fortunately for NASA, twins, so working off of the same blueprint, biologically speaking. One stayed on Earth and one went up into space, and they compared all of the biological changes that happened between twins, and we learned things like how the body responds to immune threats, such as getting a flu shot in orbit or on the ground if we were the Earth-bound brother. And this taught us a lot. But every human is different, so the more data we can get, the more clear the picture we get on how humans respond to such things.
Was there even a height difference when he came back?
There was a
Yeah,
height difference, and there was an age difference.
Age difference, yeah.
So we already covered that, but it's still amazing. It's a little biological.
They're probably gonna have a control.
Yes, it showed the
Earth.
box that they were on one of the earlier slides about AI, which it's going to feed them their growth medium, keep them fed so that they have nutrients. And because their cells themselves produce waste, they also need to remove the cell's waste material. So these little points are going to be hooked up to little support systems.
I think what is saying.
Earthbound.
Well, right, people that's
Yeah.
come on Earth.
Yes, they are going to compare them to the pre-flight samples, and the chip will also be compared to the astronaut themselves when they. Just to gauge differences between the chip and its donor. Which, this is the first use of an organ on a chip instead, but it's still cool. Yes, and this, for those who were wondering about bone, how they were bone marrow cells, when they got new blood, they were going to the stem cells that they got through the food. And it's gonna help test microgravity and radiation. This is still cool. And as I said, it's to help personalize care and also predict threats to that astronaut further down the line. And radiation sensors, they have their own personal dosimeters. They're worn in their uniform pockets, and so they will be with them all the time. And they also have some in the crew module from the two, actually, one from the German Space Agency and one by NASA. And they're also going to be itty bitty things that involved in the process. So when Orion crashes down, the health response program's mission continued because the ultimate goal is Mars. Now for my updates. Any questions on NASA stuff? Okay. Well, as I said, I got the slides from NASA in late January, and a lot has changed for Artemis. Artemis 3 is projected to launch mid-2027. And the changes are it's going to have test docking and systems in low Earth orbit, focusing on rendezvous with one or both of the planned landers, because there's two companies that have bids on the landers. And they're going to also test the new extravehicular suits, which they abbreviated this. I'm not sure why they're not just calling them EVA suits. I guess it's being fancy. The equivalent is Apollo 9 and the original lander contract belonged to space. The Gateway, which people haven't heard a lot about in some time, is a planned 4-orbit space station that would be permanently positioned around the moon with a planned duration of 15 years to serve as a base. The landers would be docked with the Gateway beforehand, with the intent of you just slide your capsule, one guy hangs out in orbit, does the microscience experiments, takes some photos of the moon, while the rest of your crew piles into the lander, land on the moon, and gets put in work to plant the lunar regolith. It will take 7 days planned. All of this is planned, and they're still refining all of this.
So will there be a lander permanently docked at the Gateway, or the guys, Orion will be stocked with the Gateway?
They're still discussing it. It sounds like the lander will be waiting for them. It sounds like the lander, one way or another, will be waiting for them before they get. Artemis 4 is now planned to be the first Artemis moon landing, with a date in 2028, no specific date beyond that. Lander contract with SpaceX. It will use the Gateway station. And Artemis 5 is also planned to launch in 2028. And building sustainable architecture on the moon, the lander contract belongs to Blue Origin. Moving forward, they plan to a manned lunar landing every 10 months. Starting with Artemis 4 landing, being our first landing on the moon since the Apollo program. The final goal remains to go to on Mars. I believe people have stopped keeping track. Because it got past the budget moving. So, any questions? I know I have covered a lot. Yes?
Would you say, I don't know, would it be Apollo missions, there were 3 astronauts, one always stayed up, 2 went down. Did you say how many go down?
They're planning for at least one to stay on the Gateway, with the rest going to the surface. The landers are built.
What is so fuel
I don't think that either company has announced that yet.
With the pilot program, we use two automatic igniters. I'm not sure that you didn't have to have it ignited to.
I'm not sure.
It's basically,
SpaceX, as I would plan, yes, is probably the standard method that they use. So whenever it burns, it produces. You don't need to be as fuel conscious with waste products as you do on the moon because there's no atmosphere.
I was in this new automatic ignited to kind of view. Hard parts are hauling carbon to the moon. You can't get carbon on the moon. So you gotta hold it there. It's heavy.
Oh, wait, no, they just burn hydrogen, my bad. I think, what's the one I do? I didn't have one with.
Right now,
No, they burn just hydrogen and oxygen and it just makes water vapor. That's where I got methane from. Maybe I was thinking of hydrogen.
Have you come across anything where they talk about potential contingency plans in case something goes wrong?
On which stage? Because there is a
Multiple stages, I mean.
there is a launch support system and per existing Apollo,
Yeah.
if a problem occurs en route, it's always free return to Jeffrey and get home.
Was there a plan for multiple Artemis on one gateway?
Oh, the gateway is going to stay there. It's going to be used by multiple missions.
Could it be used by more than one Artemis vehicle at the same?
In theory, yes, it's, most space stations are designed to have multiple docking points in the event a rescue is needed. They always like to have spare docking ports, just in case.
My son over at Stennis said that they just been notified as part of the changing that now Stennis is going to be the primary test location for stage test. So instead of testing 20, they test 5 on and they're revamping hollow testing in order to go stuff.
Oh, I missed the F1 engine. Well, they never failed, 100% success rate, but each one was unique and they were all on hand and to be full. But everyone who worked on them was retired.
And they picked the one.
Any other questions?
Aside from the obvious, what are you most excited about?
We need to go back to the moon.
Aside from.
The organ ship, those are amazing.
I can tell you that I watched, all of Lightning Land and all of the other. I've never seen time to get into our way. See the moon run by. Yeah. And that to me, water compacts reacting. That was stunning. And then everybody holding their breath for the countdown. Because I remember when the feet for 30 seconds, you only have 30 seconds to you to land. You land in just 2 seconds. Like seeing them breathe the first two with the moon on fire. That was awesome. The fun. You can still find it. I found it.
And you can also find most of the Apollo appointments.
Yeah.
And the Apollo 13 posted the most often. I wonder why.
I wonder what the percentage of our population is born. I'd say, but I mean, widespread, what population percentage?
It's most people by now,
Yeah.
Oh,
by far, most. You're just asking about actuarial people.
You need the crew, what's their sort of experience with flight? If there's specific, because I'm sure they can test it, but
They all have impressive resumes, and I cannot respect them.
That's,
Have they been to the ISS?
That I don't know. I know they've been training for this for several years.
Yeah, they took a lot of them, spent, 3 events in the,
Yes,
you know, there's a psychological assessment of the.
yes, they have those. They do those because people don't always handle being stuck in the tin can for 10 days very well. They also, I think, do psychic valves on people who are gonna be on submarines for the same reason. Okay.
Awesome.
Oop. And I'm told I'm gonna see y'all again in October for the new quick summer.
Oh.
All right, we're gonna just take a
Little 5 or 10 minute break, don't go anywhere, come back here, and we will conclude our thing. So far, I peeked my head outside. It's mostly cloudy, but there were some big holes up there, and Jupiter is shining brightly, so maybe when the meeting's done, we'll at least take a scope out and get some work done. Yeah, maybe